However, here the machine uses a model which is very closely resembling the human brain. So that's how it is different. So that's these are called neural networks. So these are called neural networks. So these neural networks are designed so that it is very similar to how the human brain works. And then it using these neural networks, we will see more subtle differences. But essentially, it's also machine learning, but it using neural networks. Then among neural networks is a special type of neural network called transformers. The transformers basically work in a manner where it takes an input and it converts the input, it processes the input and provides it to another. This is too much. Microsoft PowerPoint. Okay, it hands over to another unit where it takes the, look at that. Actually, it takes a long input and it condenses the input into a shorter space, and then it gives it to another unit where it again tries to recreate the original input. So while doing this, at this point, the machine has learned enough about the input data, and using that knowledge, it can perform various tasks. Like I can tell the transformer, okay, fine, you take my text and you you make a summary out of that. So first, it will use a network where it will understand the input, and then using this knowledge, it can try to summarize. Or I can tell him translate this text from English to Hindi. So he can do that. So transformers are there are many kind of transformers. We will look upon these things. And there is a very special kind of transformer which has become very popular, which is where now artificial intelligence has come much closer to human beings. Is that we call it generative AI. So the term generative AI basically means that AI will generate something. So I'm sure all of you are familiar with tools like ChatGPT, etc. So what are these tools? These tools are basically uh, you give an input to the machine, and the machine generates a whole bunch of output based on what the input you have given. So it can write programs, it can write books, it can write so many different things. So that it is basically generating something. That's why it's called generative AI. So so we have this GPT, which is very popular. There are other things also like Google has got BERT, and more recently Google has launched uh, Gemini. Gemini is basically a tool based on BERT. So we'll go through all these things. Now, not today, during the program. So uh, now as the complexity of the machine learning uh, increases, the amount of time and resources it needs to train the models increase exponentially. So when you come to a generative tool like ChatGPT, it took huge amount of time. It took about 100 days to train and in a very large configuration. So this is expensive. This is not very cheap, and it is not possible that everyone can create such models uh, because of constraint of time and money, both of them. So there are techniques by which we can still create models when we have such constraints. So we'll discuss those things as we go along. So I'll pause here for a moment. Anyone has a question so far?
Yeah, hi. Morning. So this Gen AI, the
And please,
next
please,
level or next is hello, I'm audible.
yeah, yeah.
So the AGI and there are many other technologies which are emerging. So beyond Gen AI, we also see in market the requirements which are coming up like your AGI, artificial general intelligence, which are more like a human thing coming out of it. So anything beyond Gen AI that is can help
Okay.
us to touch up.
Um, yeah, okay. I'm taking your question, but next time I'll not answer you if you don't raise your hand and give chance to others also. Okay.
I was trying to raise the hand, but don't know what happened there.
Yeah, please try properly. Anyway, see, AGI is a concept at this point of time, and this is a research subject. AGI basically stands for Artificial General Intelligence. So at this point of time, we are in an age where we call that we are in the age of narrow AI. Narrow AI basically means that I teach the machine one task and the machine can perform only that one task. It cannot perform beyond that one task. So it is not like humans. Because I tell the machine, okay, fine, you take this bunch of customers and you tell me how to segment them. So I teach him how to do that. So the machine can do that. Or I tell the machine, you take the weather data and tell me what will be the weather like tomorrow. The machine will learn that one task and he will predict the weather for tomorrow. Or a chat GPT, I say, okay, fine, you take a question and you provide an answer. So he will do that one task very efficiently. But then if I tell the weather forecasting machine to conduct customer segmentation, it will not be able to do because he's not been trained for doing that. So we require a artificial intelligence where I teach him one task, just like humans. We are taught one particular thing, and from that one thing we can extrapolate and learn many more things. So I teach you ABC and you're able to read books. I don't need to explicitly teach you how to read books. So we have to reach this stage of where I teach the machine one task and the machine is able to learn by itself and apply it in different tasks. So that is called artificial general intelligence. You will find that there is a lot of literature available on artificial general intelligence, and many people are claiming it is almost there. But reality is that it will take at least another 30 years before we get the first system which is got AGI. So this is not going to happen very soon. Beyond artificial intelligence, they have conceived something called super intelligence, where the machine will be doing things beyond what human beings can do. So this is even beyond, and currently the estimate is this will take at least 100 years. So uh, now, as far as the question is concerned, this program will focus only on narrow AI, and we will not talk anything beyond narrow AI. We will not cover AGI. We will not cover super intelligence. So this program will not do that. Okay.
Thank you very much.
Yes, Sandeep.
Yeah, thank you, Partha. What we are seeing on the screen, what's the best way to describe this hierarchy? I mean, this is because you said artificial intelligence has multiple branches, vision, NLP, robotics, and then we see here machine learning, deep learning. So, are these the ways this artificial intelligence work? How would you summarize this hierarchy?
No, this is a branch of artificial intelligence, and these are the components of this branch. And this basically, I am taking a generic branch called machine learning and going into specializations of it. So
Okay,
at each step, I am specializing for a particular task and using a particular technology. That's all it is all about.
okay, thanks.
Anyone else has a question? Okay. Okay. So now let's see how the machine thinks, how we can make the machine think. So to make the machine think, we first try to understand how we humans think. So this is an example where supposing you are given a lot of medicines like this. So these medicines, you can imagine they are the data which we feed to the machine. So when I give such data, the machine will, what it will do is it will try to find patterns within this data. So it will find some patterns. It will say, okay, these medicines are similar, or uh, these are closely similar, and things like that. After having found the patterns, it will draw inferences. So it will basically say that, okay, fine, I have now put all the machines for diabetes in one box. I have put all the machines for maybe cholera for in one box, and so and so. So this is the process of learning where I start with raw data, and within that raw data, I find some patterns. And after finding the patterns, I will draw inferences based on the patterns which I have found in the data. So this is exactly how the machine learns to think. Now, the process, what you must understand very importantly is that the process of finding patterns, this is nothing but mathematical models. Now, this is very important to understand, basically because you're all very senior managers having a lot of power and very little amount of time, but you have come to this program to learn about artificial intelligence. But this program I am Cozy Code has designed for you so that, because of the feedback which you have received from people like you, that you do not want to get involved in too much of mathematics or programming and things like that. That's fine. But if you want to understand machine learning, or if you want to understand artificial intelligence, if you do not go through the basic way or basic mathematics involved, you will actually not learn anything about machine learning, because everything what the machine does is based on some mathematical model. It is not arbitrary. It cannot think like we do. We also have to build our logic before we can start thinking in a particular manner. That logic, what we think, is basically because of some form of mathematics. Maybe it is or raw mathematics or augmented mathematics, but we have to learn some form of mathematics to be able to find coherence in some situation, or find differences in some situation, and things like that. So what I will do in this program is that I will discuss the mathematics um, behind the different ways the machine learns different things. Now, I will also be discussing and showing you various programs, codes, um, to perform these tasks for your better understanding. Now, the people who find interest in that, um, or who are interested or inclined towards this, can benefit from it. And the people who are not inclined towards that, at least see the process. It will help you to interact with your technical teams in a more intelligent manner, as compared to being totally ignorant about what goes on in the technical teams um, work. So you will get a better understanding of how the technical team works. And when you go back and interact with them, you will be interacting with them in a much better manner. So that's how it is, because if we ignore this part, then you will as essentially learn nothing from this program. So in the lectures, what you will see from IIM Cozy Code, there are a lot of mathematical terms, what you call discussed in a very subtle manner, so that it doesn't overwhelm you. Okay. Do you have any questions on this aspect, or because you have joined the program with a particular expectation and understanding of what the program is about, are you having any questions around what I just told you just now? Yes, Tarun.
Hi, Patu. Thank you for bringing this up. So I just wanted to understand because I'm I'm not a technical person. I'm not a programmer by by my learnings and by my what I'm doing right now. So I would like to understand that uh, after this course, will I be able to? One, you mentioned that you will be able to interact with the technical teams in a better way to understand what they are saying and get your business propositions done. But can I also build some basic models after this particular course, or can I attempt to do that to understand, how this maybe AI or any type of tool is working out?
Well, it depends on we are the program is not focused towards making you a technical person,
Right.
but if you are interested, you will find enough material what I will discuss in this program, and it will be up to you to take that knowledge further and practice and get. I will also show you resources which can help you to develop these skills. But the interest has to come from you, and you have to take the initiative.
Right, sure. And in case we find some challenge or some problem, we can reach out to you.
Yeah, the discussion forum is always there. You can ask any question there.
Sure, sure. Right. You mentioned that. Right. Okay. Thank you. Thank you, Patu.
Yes, Parag.
Yeah, good morning. Uh, just taking from yesterday's session and today's session, just want to understand the step number 1 to 3 mentioned in this flow chart. Does it belong to data science, and step number 4 to 6 belongs to artificial intelligence? Can we infer in that way?
No, let me come to this discussion. This entire thing belongs to artificial intelligence. I have not come to this stage yet, so just hold on for a moment.
Okay.
Any other questions? Okay, so let us now understand. I told you how the machine learns to do things, and now let us see what are the different steps which are involved in making a machine learning model. The first step is that we need to gather data, because machine learning, everything depends on data. And machine learning has become very popular since 2000 beginnings, basically because suddenly we had a lot of data. Why we had a lot of data? Because round about 1989, not round about, in 1989, uh, the World Wide Web was thrown open to the public. So the public got access to internet in 1989. And after the advent of internet over the next few years, people started creating a lot of content. So we had blogs and everything else, and all of a sudden, lot of data was available on the internet. And then two developments happened. Uh, we had already got systems which we used to call the embedded systems. People are still joining after 1 hour of the class. So we had systems known as the embedded systems. Embedded system basically means I introduce a microprocessor inside a machine, and the microprocessor can capture data or control the machine. Now, when internet came about, the embedded systems were put together along with the internet. So what happened was that because of this, we suddenly got some devices which you today know as IoT, Internet of Things. Now, IoT, what it does is that it is capturing data which is created by machines. So, and since machines can generate a lot of data, so from IoT devices, we started getting a lot of data. This is number one. Then what happened is that a fantastic thing happened in 2000 beginning. That was somebody discovered the social media. Now, social media started providing a lot of data. So all of a sudden, the work on artificial intelligence started around about 1940s early, but it was confined to a very small community, basically because they had to do a lot of groundwork like preparing data, etc., and small volumes and do the work. Now, all of a sudden, what happened in 2000 beginnings was that we had a lot of data, and suddenly the amount of experimentation that could happen on artificial intelligence became grew like very, very rapidly. So now the basic step, what we need to understand is that machine learning depends on data, and gathering data is generally the most expensive part of a machine learning project. This is generally the most expensive part. Now, as you will go more deeper into the program, you will do projects, etc., you'll understand that this is very expensive, basically because it requires more than yourself. You may have to pay people to get data for you. You may have to uh, do a survey going door to door and living on the road to collect data. So there are a lot of difficulties. And if you want to collect um, quality data, then you have to struggle quite a lot. And the struggle not only is a physical labor, but it requires money. It is expensive. Nevertheless, the first step is to gather data. After you gather data, you need to clean the data. Because the cleaning the data means that the data what you collect may not be all correct. Like you're doing a census for a country, all the data that you collect may not be absolutely correct. You may have collected instead of 10, sometimes you may have entered 100, or instead of writing a A, you may have written in such a manner that it looks like some other alphabet. So there are a lot of problems. So you have to clean the data. After you clean the data, then you'll have to pre-process the data. Pre-processing is required because we have to put the data in such a manner that every data point has got equal importance in the models that we will make. So we'll discuss later on what techniques we have for cleaning data, pre-processing data, etc. Once we have the data ready at this stage, the data is ready, we can start creating models. So, and we have to create a number of models, not just one. And after creating a number of models, then we will have to apply some parameters, some KPIs to understand which model is better among all of the three. So after choosing the best model, then we will put that model into production and then start utilizing it. So it's a very uh, long process, and um, it takes a lot of nuances to understand each step. So there's no step which is unimportant or easy. So each step has got its own nuances. So we'll be spending more amount of time in this part. This program will not take care of um, deployment. That is beyond the discussion of this particular program. But we will spend a lot of time on not only this, we will also spend some time on this, and we will glance through this portion. Okay. Do you have any questions so far? Yes, Shiv Kumar.
Yeah, thanks, Partha. These models which we are talking about, when you say create a model, is it all those LLM models which are available today similar to nature of that? And can we also look upon rather creating a model, get that model in-house and start building those intelligences? Is that a way?
Yeah, both is possible.
Okay.
Both
Thank
is possible. Yes, Simran.
Hey, hi Partha. So just want to understand if we distinguish the machine learning process into a thinking process that you have explained earlier. So first three step can be a part of observe some data and then create model and choose the best model would be the find patterns.
No, this whole thing goes,
Okay, in the create models.
yeah.
Okay, thank you.
Anyone else? Okay. So let's move forward. Now, you need to understand that there is a um, paradigm shift between programming for normal programs. Many of you may be computer programmers, many of you are not. But in either case, you can understand that in normal programming, what we do is that we have data and we have some rules which have been observed from physical um, observations. And then we give the machine the data and the rules and we ask them to generate output. A simple thing like supposing I tell the machine, okay, fine, I'm telling the machine that the rule to calculate simple interest is PRT. So this is the rule which I will tell the machine that apply this rule. So and applying this rule, you can generate an answer. So then the machine will say, okay, fine, give me P, give me R, give me T, and I will calculate the simple interest for you. So is this not how you program your normal programs? Or you tell the machine, okay, fine, this is my basic salary, this is my HRA, and this is my special allowance, and so, and give him the tax rules, and tell the machine that, okay, fine, calculate the salaries of all the employees at the end of the month. Right. So this is what the machine is basically doing in traditional programming, where I'm giving the data and I'm giving him the rules and he's producing output. Correct. Is there any question on this? Okay. But in machine learning, the whole thing changes. Now what I do is that I give him the data and I give him the output and I tell the machine, you learn the rules yourself. Okay. So supposing I tell him that if I deposit 10 rupees at 5% interest rate and for 1 year, then you are likely to get how much will this be? 105 rupees. Right. Like this, I give him a lot of data. So this is the input and this is the output. So I give him both the input and the output and tell the machine that under these input conditions, these should be the output condition. So machine will take all this data and it will learn to map the input to the output. And it will say, okay, fine, I've understood your understood your data and I have formulated my own set of rules. So he will create his own set of rules. And then when you give him a new data, a new value, let's say 20 and 5 and 150, this is 10.5, 5% and 1 year. Then he will do the calculation based on the rules what he calculates and then he will give you an answer. right? So this is what happens in a machine learning programming, where I do not explicitly program the rules. With the rules, the machine has to learn himself. Now, this can be understood from a joke someone prepared on machine learning. So a guy went for an interview. So the interviewer asked him, "What is 2 into 2?" The guy says 9.5. The interviewer says, "Okay, try again." He says it's 6.21. He says, "Try again." He says it's 4.11. He says, "Okay, you are selected." So, though it's a joke, but this is actually what is happening in machine learning. It creates its own formula, and it will then apply the formula to generate an answer. So this is a big change from traditional programming, where I had to know the exact relationship between the different inputs, and then I had to give a formula for creating the outputs. But in machine learning, you don't have to do that. You just take the inputs and you take the outputs and give to the machine, and the machine can learn all the things by itself. Okay. Now, when it comes to deep learning, there is a further change. That is, in machine learning, what I have to do is that I have to tell the I have to tell the machine, okay, fine, these are your inputs or these are your features. Like for example, supposing I have to tell the machine that this is the principal, this is the rate, this is the time period. I have to tell these features to the machine, and then only it can learn effectively. So I have to do something called feature engineering. And after I tell him the features, then it can then it can create an algorithm and apply the algorithm and create predictions based on that. Neural network, what happens is that I just give him the data, and he will find out what are the features and what is the relationship between features and within features, and he will create a model, and that model will straight away start preparing outputs. Okay. So did you understand this PowerPoint is too much? It always troubles me. Okay, did you understand this concept between traditional programming, machine learning, and deep learning? Any questions? Yes, Krishna Verma.
Hi, thanks. So just a quick question that, okay, when we say that it will provide output, so yeah, it is predicting, and then when we say about the machine learning, the data plus output equals to rule, so it must be creating some using that some model and then algorithm, then processing, right? The same way, I mean, to produce that prediction.
Yes, of course.
Right, it is I mean, when we talk machine learning, when we say it's processing, it's a lot that creating that model or applying those algorithm, correct?
Yeah, yes.
Okay, thanks.
Yes, Praveen.
Can you explain feature engineering a little bit more elaborate, please?
You're supposing you have a problem where you have to predict the price of a house. So I have to tell the machine that, okay, I'm giving you the features regarding number of bedrooms, number of bathrooms, um, number of baths. Then I have to give him things like what is the uh, area. Then I have to tell him how far this house is from the bus stand, from schools. So these are all data which I'm collecting and providing to the machine. So these are known as independent variables. So these variables do not change because I'm gathering this data and giving it to the machine. So in machine learning, what I have to do is that I have to be very explicit. I have to gather this independent data and explain to the machine that these are independent variables, and I have gathered this data, learn from these independent variables to generate the dependent variable, which is my price of the house. In deep learning, I don't have to do this particular step. Instead, the machine will take it upon itself to understand the features and apply the mathematics to generate the rules from these features. Does it make it better? Yes, Kumar.
Hi, Pasha. In continuation to the same discussion, feature engineering is something that we do once, and then the machine itself adapts to any evolutions in the feature, or there is, a repeat instruction to be given by us.
The feature engineering is normally done a few times, but not once. I cannot say once, because what happens is that before I can create a model, I have to do feature engineering to ensure that I have identified all the different independent variables on which the machine has to model itself. But then what happens is that data sometimes changes, and the question of the problem also changes. Because of that, I have to redo the feature engineering and again retrain the model. So that is what happens. Okay.
Got it. Thank you.
Yes, Praveen.
Yeah, let us say if I gather the data, if I am using a machine learning algorithm, I have to separate the data based on the area, location, distance from the stop, or all of that. At a manual level, I have to separate the data and then feed it to the algorithm. In the deep learning, I just get the raw data and feed it to the algorithm or neural network maybe. Is that right understanding? I don't need to process the data.
It is
All
right
right.
understanding to an extent, but where the understanding is not correct is because if you say that I will not process the data, then it is not correct. Because you
Okay.
have to do some processing. Only thing is you will not do feature engineering. Okay, why processing is required also you must understand. Basically because supposing I have a data where I have gender, and gender is written as male for M for male and F for female. Now, under this circumstance, if I give this data to the machine, he will not understand because he understands only numbers. So I have to process this data and tell him that, okay, fine, this is what is male, maybe represented by a 1, and this is what is female, represented by a 2. And I tell him, now you carry on. So pre-processing is something which we cannot escape, but we can escape the step of doing feature engineering in deep learning.
Thank you. Got it.
Sandeep?
Yeah. So in these models, how do we make sure our prediction is as close to the reality as possible?
We have various metrics. We check against the metrics.
Which means it applies to historical data only then, right? That's how you can check like the census you say example you gave earlier or something like that, right?
Yes, I have to have historical data based on which I can check whether the predictions are correct or not.
Okay.
Any more questions on this? Okay, so let's move forward. Now, in machine learning, we basically two branches. One is known as supervised learning and one is known as unsupervised learning. In supervised learning, what I do is that I give the machine, like we just discussed, we give the machine some features. It can be one or more than one feature. And I give the machine the output. So this is the output. So based on these combinations of input features and output, the machine will create some rules. So the machine will learn based on what is the kind of data which I'm giving him to learn from. That's why it is called supervised learning. So in supervised learning, I can perform two kind of tasks. One is called as regression task and one is as classification task. So regression task, you can understand like I say predict tomorrow's temperature in Bangalore. So it will produce a value which will be something like, maybe it will be 31.54. Okay. Or I can show him pictures of myself and tell him, okay, fine, tell me uh, where was this picture taken? So he will give a discrete answer, like he will say, the picture was taken in Delhi. So this is a discrete answer. So we basically have two kind of outputs here. One output is called, this output is continuous. And this output is discrete. So when the machine produces continuous output based on a prediction model, we say that we are doing a regression task. And when the machine produces a discrete output based on the inputs, we say that we are performing a classification task. So this will become more clear as we discuss problems. And we will discuss a lot of problems. So this will become more clear. But for now, understand that regression task produces a continuous output, whereas classification task produces a discrete output. But to produce this output, it has to be provided data. So the feature and the output. So it will learn from the combination of feature and output to be able to produce, predict future based on the new inputs what you give it. So any questions so far? Yes, Simran.
So in the continuous output, can we expect different output if we are executing it multiple times?
Yes, you can.
And whereas in discrete, it would be static, or there also we can expect different output every time?
It can, you can expect different outputs. Not that the machine will always output the correct result. You have to check whether the output is correct or not. That is the evaluation which you will do. So,
Okay. Thank you.
okay. Now, contrary to supervised learning, unsupervised learning is an area where I only provide him the input. I do not provide him this part. And I tell him, I only provide him some inputs and I tell him to learn from this data. So based on this kind of situation, I can solve problems like clustering problem. Okay. So I can solve problems like clustering. So for example, I give him a lot of customer data based on two parameters, and I give him the task, okay, fine, you find which customers are similar. So he says that these customers are similar, these customers are similar, and these customers are similar. So this is a typical clustering task. Now, clustering task is unsupervised, where I do not tell him in advance what the answer should be. In supervised learning, I'm telling him in advance the answer which I'm expecting. So he's learning from the question and the answer. But in unsupervised, I only give him the input and do not give him any solution for the input. It has to create a solution all by itself. Okay, a special case of a clustering problem is known as anomaly detection. So anybody who is in a kind of fraud detection uh, service, like in bank or insurance or whatever it is, you will be knowing that what is anomaly detection. We will see some examples in later on classes. Okay. Another big problem which we have is we have data which has got a lot of inputs. So this inputs can run into thousands or 10,000s and things like that. So when we have such input, we cannot visualize it, or it becomes very difficult to compute such input to produce manageable outputs. So we can condense these large amount of input features that we have into a smaller set, maybe 2 variables or 3 variables. And this is without losing any characteristics of the underlying data. I can do that. So this kind of problem is known as dimensionality reduction. So today I'm just introducing you to the terms. I will show you concrete examples later on in the program. When we have sections for each one of them, and we will discuss concrete programs to do this task. Today, as long as the term registers in your head, I'm happy. Okay. So do you have any questions so far? I will give you 5 minutes time to think. I'll just take a break because I've been talking for an hour almost. So I'll take a break for 5 minutes. So in the meanwhile, you can think about if you have any questions and you can ask me. Okay, so see you in 5 minutes.